Okay, so what we're asked to do is to factor this cubic function. So this is a rather complicated process, but it first starts off with kind of a guess and check, and that comes from our remainder theorem, and afterwards it goes back to more traditional options for factoring. So we start off with our function up here. Now our analysis says, we can use our factor theorem using that form that we learned, the ax minus b, and then we can use that, finally divide that factor out if we find it, in order to find the rest. So here's our notes. For our ax minus b, that's the factor that we're looking for. So it notes that a must be a factor of the coefficient of the leading term 5x cubed. Okay, so for that, if we're looking at 5x cubed, the 5 can only be made with a 5 positive or negative, or a positive or negative 1. Okay, so that's the only things that we can have here. Now, in B, must be a factor of the constant term of negative 3. So we have this negative 3. That can come from positive and negative 3 or positive and negative 1. So we're going to try a few different options here in order to figure out what our answer is going to be. Okay, so why don't we try first, let's say, why don't we try, we'll try 1, so let's try x, minus 3. So this would give, our a is going to be, and this is just a pick, you're just picking 1. It's always good to start with 1 at the beginning, I think. So a is going to be 1 and b is going to be 3. So our b over a is going to be 3 over 1, which is 3. So we're going to go from here. So we're plugging in our 3, so we're going to get 5 times 3 cubed minus 9 times 3 squared minus 17 times 3 minus 3. So 5 times 3 cubed, 3 cubed is 27. 9 times 9 minus 51 minus 3. So this is 5 times 27 is 135. This is 81, this is 51, and this is 3. Well, if you run through this math, you actually do get that remainder is 0. That means that x minus 3 is a factor of our greater function. Now, let's say you failed and you ended up getting a remainder here, picking a different combination. That just whittles down the combinations that you can try. I would always suggest picking an a value of 1 to start if you can, and then that would generally be associated with the higher value of b. Normally, if you go with a high value of a, go with a low value of b, and likewise. But this was just, we picked it, we found that this works. You can pick other options, and still, by trial and error, you could figure this out. But factoring cubes is a little more difficult. So this is the one way that we can do that. So we've found that x minus 3 does work for us. So now what we do is we divide. So we're going to get x minus 3, oops, and we're going to divide by 5x cubed minus 9x squared minus 17x minus 3. So remember, and I actually learned this today, there's a simple little kind of mnemonic to remember this, and it's D M S B R. Don't make soggy bread red. Don't ask me where I got this. It's a little nutty, but at the same time, it does work. What this means is it means you divide, you multiply, oops, you subtract, you borrow, and then you have your remainder, or you reduce in your remainder. So on. So this is just a way to kind of keep things in track for you. So don't make soggy bread red. So the first thing is we got to figure out, okay, well, what do I multiply x by to get to 5x cubed? Well, that's going to be 5x squared. You then multiply down by each. So this should be 5x cubed. This is going to make negative 15x squared. And then we subtract. So when we subtract, this becomes 0 as normal. And then we have negative 9x squared minus a negative 15x squared. So that switches. This becomes 6x squared. And then we borrow our terms from the top. And we're going to repeat. So x times what makes 6x squared? Well, that's going to be a positive 6x. So then we multiply it down. So 6x times x makes 6x squared. 6x times negative 3 makes negative 18x. And then we subtract. This makes 0, cancels. Negative 17x minus a negative 18x makes a positive x. We borrow our negative 3, and we repeat again. Well, x times what makes x? That is a positive 1. And you'll notice that when we go forward and we put this down, this will be x minus 3. We end up with a remainder of 0, which is what told us that we were going to get from our remainder theorem. So exciting how that all works. So now we have a new divisor here, which is 5x squared plus 6x plus 1. So we have 5x squared plus 6x plus 1. So now we are going to try to factor this. Okay, so first step when we factor is we set up our brackets. We're then going to say, okay, well, two numbers together that make 5x squared. Well, we knew earlier that, and we can disregard those negatives from earlier, but the only way to multiply to get 5 is 5 and 1. We're not dealing with fractions or anything like that, so we're just going to do 5 and 1. So since we have an x squared, we're going to have 5x, and we're going to have 1x, or just x. We then need two numbers that multiply to make 1 that are going to counter here to add up to make 6x total. Well, you should see that this is going to be a positive 1 and a positive 1. So we end up here, right? If we were to multiply this out, FOIL, this makes 5x squared. Our outside makes a positive 5x. Our inside makes a positive x. And our outside makes a positive 1, which is the same thing that we had on the top. So we now have this as a factor. Now we bring down our x minus 3 from earlier. And we have completely factored our equation, right? We know that 5x cubed minus 9x squared minus 17x minus 3, well, that breaks down into x minus 3 times 5x plus 1 times x plus 1. So we needed to guess and check to find this, and then we had more traditional methods to find this part. This is a rather complicated procedure, but it's something that we can do using a remainder theorem and using what we know about factoring.